Hello, welcome. Let's try to solve another Leetcode problem. 1041. Robot bounded in a circle. So let me first explain the problem. So from the beginning, so this is a person. So it is on a plane with the x and y coordinates. So this is the x and this is the y coordinates. Yeah. And from the beginning, this person is directed to the north direction. So this is from the beginning, directed to the north direction. Yeah. Now, this person gonna have three different kind of directions. It can be G, L, or R. If it is G, it will be go directly to the north. If it is L, it will turn the direction to the left with 90 degrees. So basically, it is anti-clockwise. If it is L, or if it is R, it is clockwise. Yeah. So let's first try. Let's just try the first example. So first example is north, north, G and G, north and north, and then left and left. Yeah, it means go down. So first of all, this is north, one position, north another position. It's gonna be here. Yeah. So direction is north, and then turn left and turn left. It will go back. Yeah. So it will go another direction. It will go the south and go south. So it means it will go to the original point, which means it is 0 and 0. So this is going to be the original position. Yeah. So this means if we are giving an instruction, and if this instruction can make the position go to the original position like 0, 0, definitely it works. Because if we give another direction, definitely it can go back. Yeah. So this is like a loop. So for example, if we give another direction, so it will just go down, and turn 180 degrees, go back and go back. It will go to the original position. So this is one case. Yeah. So another case is that. So for example, if we only have this G and G, is that possible? So definitely it will go north, go to the north, and next it will go to the north and go to the north. It will directly go to the north. It means it is not possible. Yeah. But what if we give for example with GL? Yeah, we go to the north and turn 90 degrees anti-clockwise, and then we go to the west, we go to the south, and we go to the east. This means we can go back. Yeah. So the condition is that after one instruction, yeah, so after this one instruction, if I can go to the original position 0, 0, this means it is okay. Or I can go to a different direction. So for example, this is north, this becomes west, or it becomes east, or it becomes south. If it go to a different position, different from the north, definitely it works, because we're gonna have many instructions, and how many instructions will make it go to the original, will make it a loop? Definitely it's gonna be 4 directions. Yeah. But at most it's gonna be at most 4 directions. Yeah. But we don't need to check 4 directions. We just use we don't need 4 instructions. We only need 1 instruction. That is okay. We just need to check if we can go to the original position, or if we can go to a different direction. If it is not equal to the north, definitely it also works. Because if we use many instructions, definitely it can go back to the original position. Yeah, go back to this 0 and 0. Now, what are we gonna do? We're gonna prepare some state and direction. So let me just prepare a position. So the position gonna be 0 and 0, and let me prepare a state. State means the direction. Maybe let me prepare a direction. So the direction gonna be equal to n. So this n means it is it is north. So from the beginning, I am directed to the north. Yeah. Now I'm gonna check the instruction one by one. So for I in instructions, now I'm going to check this I. So if I equal to G, yeah, basically I need to check the state and check the direction. So if direction equal to n, I'm gonna update the position. Yeah. So the position gonna be so position 1 gonna plus equal to 1. So if direction equal to s, so position 1 gonna be minus equal to 1, and if the direction equal to the east, so this means the position 0 gonna plus equal to 1, and if direction equal to the west, so this means position 0 gonna minus equal to 1. Yeah, so this is exactly what we are doing for simulating the problem. Yeah. So now, what if this I equal to the left first, L, and we need to check the direction, because currently we are not sure what is the direction. So let's just copy it. So here we need to use elif, because for the for checking we need one of them. We don't need to check many of them, so we need to use elif. Yeah. So if the direction are equal to the north, we're gonna update the direction. So if it is the north, it's gonna go to the west. So if it is the west, so the direction gonna go to the south. So if it is the south, so the direction gonna go to the east. So if it is the east, so it will go to the north. Yeah. And similarly, we can directly copy it and try to check another way. So this means if the instruction equal to the R, basically, if this is a north, it will go to the east. So if it is east, it will go to the go to the south. If it is the south, it will go to the west. If it is the west, it will go to the north. Yeah. So this is just clockwise. Yeah. So finally, we just need to check the final state or final position. So we just needed to return position equal to 0, 0, or direction not equal to the north. Yeah. So this is exactly what we are doing for this problem. Yeah. Now as you can see, it works. Now let me just submit it to check if it can pass. Now as you can see, it passed for all testing cases and it's pretty fast. So there are going to be many different ways of encoding the directions, but I think the direction like using a north is going to be the easiest way. Although there's a lot of coding, but basically we can avoid making mistakes, because in mathematics, if we are calculating the direction, definitely it's easier to make mistakes. But if we directly use a direction with this n, and then we're gonna change the direction with 4 different characters, so basically we can avoid a lot of mistakes. I think that's all about this problem. Thank you for watching. See you next time.